All right, so here's an actual working model of the universe. Now, scientists always ignore the laws of thermodynamics, but you can't ignore thermodynamics in a system, which is the universe, that is only basically thermodynamics, hot and cold. They have the universe starting at really, really hot, but it had to be cold before it got hot. Temperature works as its coldest state, then it starts to warm up, then it's its hottest state, and then it starts to cool down, and then it's cold again. So let's start here. Dot theory, pointillism. Now they call it string theory, but if you take a dot and you run a frequency through it, you get a string. So it should be just dot theory. We live in a binary dot matrix. So let's start with just the void of space. Nothing, just nothing, which is still something. It's infinite square area, making space a superposition. Now it's really cold, negative 460 at least. Now there's a high volume of electrons, volume, and there's zero viscosity here. Now the electrons are ushered in basically by space roar. Space roar is a sound frequency. Now you can't hear anything in space, but that doesn't mean there's not frequencies in space. Because space is big, it's just a giant echo. And we know through sonoluminescence that sound ushers in light. So over time, these electrons, because it's a static space itself is static, it's eternal. It has no beginning, no end. You can't measure beginning, can't measure an end. It's just infinite, dark, cold space. And it's going to start at the lightest particle, the most fundamental particle, which is the electron, because everything is the electron. And the universe is going to inherit traits from space, like being static. That means basically it transforms from energy to matter to energy to matter, energy to matter, statically forever. So let's start here at absolute zero, negative 460. Well, a little bit colder than absolute zero. Everything has zero energy. It's electrostatic. It's X, because the space is a womb. It's an X factor. This ties in with Taoism, male and female entities, because it's real. Why an X? It has zero viscosity, zero resistance. It's just leptons, electrons. They have no color charge. So you're going to go from no color to having color. It's dark gamma radiation, like Cherenkov radiation, essentially, and synchrotron radiation. It's superconductive because there's no resistance and zero viscosity. The colder something gets, the more properties apply that are indicative to super, super cold properties. So since there's all these electrons here, that's conservation of energy right there. The universe in this aspect is just a heavy, gigantic, static graviton. It's dark light, and it's light, meaning photons are technically heavy light, and neutrinos are light, but you have no neutrinos yet. So this is x squared, or E squared. Energy equals mass, which equals weight, which is heavy. The first law of thermodynamics, conservation of energy and momentum. The uncertainty principle, absolute zero. So we're going to start right here. Now that goes from absolute zero to about negative 454, which is a muon, which is here. Now the muon will decay into a muon neutrino and an electron neutrino, and into an electron. But the electron does not decay into anything, making it the most fundamental particle. So at this point, you could consider this a flat equilibrium. It's sparse, similar to a cloud. A cloud is really, really heavy, but it's scattered over a large distance, giving it buoyancy. So now you have false vacuum decay. It's going to start collapsing and getting denser and denser. This is bubble nucleation here. It's like a wave collapsing. Now, because space is a 1 and 0, because it's infinite square area, making it something, but it's nothing at the same time. This would be Schrodinger's equation. The cat's dead and alive at the same time until it's observed. Now, technically, Schrodinger's equation, converted into a heat equation, is where this would coincide. So now we're at the muon stage. Now, the space in between these particles is negligible, because even if I zoom way out here, all these little dots here become one giant dot. You don't see the space in between. So it goes from a negative 1 to a neutral, which is the singularity, to a positive 1, which is the universe we know. And the math only takes us so far, to about right here. But all of this can't find out with math because there was no math. We can't calculate something whenever it didn't exist yet, but it did exist. Because we know now, because of the probability and certainty that the universe does exist, that this had to happen through observation. So you have muon catalyzed fusion at this point, and you have dark light and neutrino emission now, Cherenkov radiation. So it's warmer than this, but it's still really cold. Now you have a probability amplitude of Q because it's unobserved. And now you're at the tau here. Now between here you have a pion, which is gaining color charge. It's trying to induce nucleation itself, or induce the conception or birth of a universe. So at this aspect, it's losing entropy until the universe is born, and it starts gaining entropy. Now technically, like gears, you have right spin and left spin when it comes to particles. Particles, which are regular particles that we know, and then you have antiparticles. Now technically, antimatter exists within quantum particles. And that's what gives us what we see. It's a flux. It's like a micro explosion. It keeps exploding, it keeps exploding, it keeps exploding, which is the flux that we see and the vibrations that give us solid mass. Now, space gives fluidity to everything that exists within it. And the particles are just gaining energy and mass. So it's moving toward this way. And then when you have the singularity, you have the quark-gluon plasma. This is the Born probability. Now, technically, the Higgs boson, or the singularity, has a spin of 1, not 0, as it claims here, because it's relative to fifth-dimensional hyperspace, which means it's the only thing within that spatial area. So if I'm tied to a rope looking at it and I'm spinning, I'm not going to be able to see any spin. If I'm looking straight back at black space, I'm still not going to be able to see any spin. There's no relative movement. So it goes from potential energy to kinetic energy. So this would be Y pi. And it has no viscosity, almost no viscosity. There's no viscosity here, and it has almost no viscosity here. And that mass, which is the singularity, is going to expand or inflate or explode, whatever, c2 at the speed of light squared. And it's going to drop from that fifth-dimensional relativity into a fourth-dimensional relativity with a three-dimensional realm, which is 3 dimensions encompassed in time, which is the fourth dimension. So now there's a viscosity of about 20 Pascal seconds. And now you have true bright white light, which is heavy light. And that singularity gives spin and angular momentum to everything to keep from collapsing. Because at every point you look, every point of resolution, everything wants to collapse. But since it has color charge angular momentum, it can't collapse. It's fluxing. So micro antigravity is color charge and macro antigravity is dark energy. So now you have certainty, which is a coherent superposition. Eigenstate equals R because it's observed. So now you have entropy, time, dark energy, and kinetic energy, which are all the same thing. And the singularity itself, which is the hottest, the quark-gluon plasma, is actually going to cool and go through stages itself as it's inflating. When you look at the HR diagram, this helps us understand what it's going to do. Because it's going to be blue at this point at the very, very, very hottest. When it starts to cool, it's going to turn white, and then it's going to start tapering down to a yellowish, and then an orange, and then red. And it's going to be red shifting. And that's why we see it like this. That's what this means. This is white light altogether. This is a clue. So you have the infinite spatial dimension with a temporal dimension within it. Now, the top quark has more mass than the Higgs boson, but the Higgs boson does have that one spin. And what it's going to do is it's going to trade that spin for mass. So it drops to a top quark, like I mentioned, it drops to the fourth dimension with a three-dimensional realm, and it's going to drop to a half spin. But it's going to raise its mass. That top quark's going to decay into a bottom quark, the bottom quark's going to decay, and they're all basically going to start decaying until it evens out to a tapered up and down quark, which decay into each other. Now it's stable. Now atoms can form. Neil deGrasse Tyson gives us mixed information and false information. He'll give you 99% truth and 1% lie, but that 1% lie is very important. He says cold doesn't really exist. Everything is only cold. If you remove all the heat from the universe, you only have cold. So it had to start with cold, logically. That's not an opinion, that's a fact. That's a logical fact. It's just common sense. But then he'll argue that nothing is supposed to make sense. It's under no obligation to make any sense, in his words. Well, science is supposed to make sense of things. That's the whole point in science, to understand things, not just to make nonsense of it and say it's not supposed to make sense. And if you pay attention to what he even says don't take what he's saying for a fact, look into it yourself to find out. Because he has to follow a narrative too. They throw out the conservation of energy. You can't do that. You can't throw out thermodynamics. That's what this machine called the universe is. It's a giant nuclear reactor of temperature. Degrees, which are circles, and temperature. The universe is essentially a water cycle. It goes from a Bose-Einstein condensate. It condenses condensate because it's fluidity, the waters of space, the waters of the universe. And when the universe is born, it rains and hails because rain and plasma are one and the same. They're water, they're liquid, they're fluid. Hail is hard. It's made of the same stuff, but it's in a colder state, giving it a solid structure. That would be analogous to moons and planets and such because it's rain and hail. It's a giant water cycle. Look, I'm just going to say perspective is everything. If your perspective is obscured, then it's easy to be lied to. But if your perspective is straight, you can't be lied to because you see with real eyes. You realize with real eyes. The simplest way to understand this, besides temperature, is just track the decay of particles. You track the decay and then you just run it in reverse. I mean, that's all you have to do. Look, I'm just saying, Michael Faraday wasn't a mathematician, but he was a very accomplished chemist and physicist and understood electricity at that time better than anyone. This also ties to wave-particle duality. There was a singularity, and then there was a prior to the singularity. The math takes us right here where everything's just hot and on. But we know with common sense that things are cold before they get hot. So it starts at absolute zero, maximum buoyancy, you might say, because it's sparse. It starts to condense, gets to its focal point, then it expands and inflates. And eventually it's going to reach absolute zero again, the heat death, and then it's going to do it again because it's a wheel. Everything goes to where it's coming from, and it comes from where it's going.